A very good afternoon to our lecturer, Eunchae Rosli. My name is Shin Kai Shen, metric number AA2322452. And today my group will present solid mechanics project on a container crane. So these are my group members. You have myself, Shin Kai Shen. We also have Arthur Ang Junrong, Chai Juan En, Ki Jia Le, and also Lo Jiaqi. So now I will start out our group presentation with our introduction. So in this solid mechanics project assignment, you analyze the container crane structure integrity. Container cranes are important structural elements in a wide range of engineering applications, including lifting, transport, and also machinery. Understanding the container crane reacts to different loading conditions is important in ensuring the structural integrity and performance of the machine. Secondly, the primary objective of this collaborative project is to construct the container crane and conduct a comprehensive analysis of its mechanical behavior under device loading conditions and the beam configurations. Through an examination of the stress and strain distribution within the beam of the container crane, we can conclude that the distribution of the shear force, bending moment, bending stress, torsional stress, and hoop stress and longitude stress in a thin wall pressure vessel. This analysis will provide a deeper understanding of the beam behavior and enable us to assess its strength and stiffness. So now I will talk about the objective of our group project, that is to calculate the stress and strain of the container crane beam, calculate shear force and bending moment, calculate bending stress, and calculating torsional stress. Also, last but not least, calculate stress and longitudinal stress in a thin wall pressure vessel on the container crane. So these are the areas of study of the container crane that we are going to study. We have where the longitude stress and hoop stress is going to be calculated, the bending stress, the torsional stress, and also the bending moment. All of these are the places that we are going to calculate and we are going to study on the container crane.
My name is Sai Sonan and my matrix number is A23259X. Today I would like to present about my part is stress strain. In my question, a 40 tons container is lighter by a container crane with a 50 millimeter diameter steel cable. Where lifting the container, the cable extended by 8 millimeter over a 25 meter length. The mass is 40 ton. Convert to kilogram is 40,000 kg. The force is mass times gravity. So equal to is 392400 Newton. The diameter is 50 millimeter. Convert to meter is 0.05 m. The original length is 25 meter. The extension length is 8 millimeter. Convert to meter is 0.008 m. The last one is a Young modulus is 2 times 10 power 11 Pascal. So in the first question, calculate the stress. A equal to id squared over 4. You can get the answer is 1.9635 times 10 power negative 3 m squared. After that, we can stress is equal to F over A. The answer is 2 times 10 power 8 Pascal. The second question is calculate the strength. The strength equal to delta L over LO. So the answer is 3.2 times 10 power negative 4. And the last one is Young modulus. So the E is equal to stress over strength. So we can get the answer is 6.25 times 10 power 11 Pascal.
Good morning. My name is Lojachi and my machine number is AA23409. Now I want to talk about the calculation of the shear force and bending moment. So from the question 1, we get the mass is equal to 40 ton, which is 40,000 kilogram. So first we use the W equal to mg to find the W. So the answer is 392400 Newton. So then we use the total moment equal to 0 to find the RB. So the RB is equal to 294300 Newton. Then we use the total Fy equal to 0 and the Ra is 98100 Newton. Then we also use the total Fy equal to 0 to find the V from the X is from 0 meter to 50 meter. So the V is equal to 98100 Newton because V is constant with the Ra. Then from the X equal to 50 meter, the V is negative 294300 Newton and the 50 meter to 20 meter. So the X is equal to 5 meter and the V we get is 0 Newton. So from the moment, the X is equal to 0, so the moment is equal to 0 Newton meter. And from the 0 meter to 50 meter, the moment that we get is 1471500 Newton meter. So from the 50 meter to 20 meter, the moment that we get is 0 Newton meter. So in my right hand side is the diagram of the shear force and the bending moment. Thank you.
Good afternoon, my name is Arthur Andrunong and my metric number is AA2325 and 34. I will continue a presentation to calculate the bending stress. For the formula of bending stress, which is sigma equals to my over I, m which is maximum moment, and we can take the value from the last question was already calculated by Jachi. And we use the table to find the total area and the total area times y. To find the natural axis, we use the formula y equals to total area y over the total area. So we can get the value of y, which is 120.845 mm. And to calculate the inertia, we also use the table to calculate the BDQ over 12 and to calculate the AH square. And we get the value of the I is equal to 0.02349 m power 4. And for the y, we use the total height to minus the natural axis. We get 0.1792 m. And we fill in all the value, we can get our final answer is 10.975172 m Pascal.
So thank you to our previous presenter, Arthur Ang. So now I will present my part of the calculation on the container crane. So my part will be calculating the torsional stress on the DC motor. So each container crane has two 650 horsepower DC motors running at 900 RPM with a shaft diameter of 0.8 meters. So using the formula of mu equals to 2 pi over 60 times n, that would be calculating the mu. So finding the mu, we will convert the horsepower. So 1 horsepower equals to 0.7457 kilowatts. So converting 650 horsepower into kilowatts. Now, using the formula P equals to torsion times mu, we can find torsion. So after finding torsion, using the formula of T tau max equals to T times the diameter of the shaft over the J. So how do we find J? So J is equal to pi d power 4 over 32. So after finding J, we can put everything into the torsional stress maximum formula and finding that one motor powering the whole entire container crane runs at 51.17 Newton per meter square. So if we times 2, we'll have about 100 something Newton meter square in 2 motors of a container crane. So that is my part of the calculation. Now we will continue with Kijala on the next part of the calculation.
Okay, my name is Kijala and my metric number is AA232599. So I will continue the presentation. For my question is, a thin wall cylindrical pressure vessel used in a hydraulic system has a wall thickness of T is equal to 4 mm and the diameter is 25 cm. The vessel is subjected to an internal pressure of P is equal to 5.5 megapascal. So calculate the longitudinal and Hope stresses in the thin wall. So you can look for the solution. They have a figure of the question. So we can use the formula stress is equal to PR over through T to find the longitudinal stress. So we find the radius from the diameter over 2 and we will get the 12.5 centimeter for radius, and we change the centimeter to the meter, we will get the radius is 0.125 meter. And also we change the thickness from millimeter to the meter and we will get the answer is 4 multiply 10 power negative 3 meter. And then we put the value into the formula and we will get the longitudinal stress is 85.94 megapascal. So next we find the Hope stress using the formula is stress is equal to PR over T. And also we put the value into the formula and we'll get the final answer of the Hope stress is 171.88 megapascal. Thank you.
So now, finally, I will talk about conclusion to our mini project. So in conclusion, through the mini project on conducting a container crane has provided valuable insight into a behavior and efficiency it under various loading scenarios. So the main 4 components of our finalized conclusion, that is, this experiment effectively demonstrates the stress of the container crane beam under various loads. The experiment allows us to observe and analyze the stress of the container crane supporting an object, and also calculating the torsional stress on the motor, and finally calculating the pressure of a thin wall vessel in a hydraulic system of the container crane. So that is our group presentation. Thank you to Encik Rosli for watching, and thank you very much.